Okay, so it turns out that the completable futures framework, much like parallel streams framework, has evolved a bit over time. And so we're going to talk briefly about some of the newer features that were added in later versions of Java. So there's a number of enhancements that Java 9 added to the completable futures framework, which first came out in Java 8. These are some of them. There's a few more, but they weren't as interesting to me as these ones were. One is that you can now have a factory method that returns the default executor. So if you don't provide an executor, it'll use the default executor. Before, it used to use the common fork join pool, but now you can specify what you want the default executor to be, so you get some more control over that. There's a very interesting method called complete async, which can be used to complete a completable future asynchronously. And it's kind of a dual method to the complete method. There's a complete method which you can use to give a value, and complete async can be used to asynchronously get a value. And I'll show you how to program that in a second. Then there's a couple of other extensions that were added to handle timeouts. One is called or timeout, and this will basically set things up so that if a completable future is not finished by a designated time, then a timeout exception will be thrown. And then the last method we'll talk about here is called complete on timeout. And what this does is, if the completable future does not complete by the given time, then a default value is given as the result. So those are 4 extensions. So let's go ahead and take a look at how you might apply these techniques. So the first thing we're going to look at is using the complete on timeout and or timeout extensions in Java 9 to fix some of the limitations in Java 8 with respect to timeouts. And you can see the example if you go to this folder. You can find this code and play around with it. So what we're going to do here is we're going to have a little program that will asynchronously find the best price for a flight. A little bit hypothetical here, but we're going to assume we have some kind of system that's going to go out and find the best price for something. And so you can see that find best price is a method that will be given a starting location and a destination, and a departure airport and a destination airport, and it will asynchronously go ahead and find the best price. Okay, no real surprise there. That's pretty straightforward. Obviously, under the hood, supply async is going to use the default executor, which in this case is the common fork join pool. We will then also check to see what the current exchange rate is for pounds for pounds. So like, what's the exchange rate of dollars to pounds? And we're going to query that. And that also might be a web service, so it may take a little bit of time to run. So we're also going to asynchronously query for that as well. And what we're going to do here is we're going to say, if we don't get a result back from our web service in 1 second, then we're just going to go with some default rate. And so if the thing takes too long to run, this should be if the call takes more than 3 seconds, 1 second rather. If the timeout here, if the thing takes more than 1 second, sorry, to come back with the exchange rate, we're just going to give it the default rate. So that's what complete on timeout will do. We're then going to go ahead and use the then combine operation, which is the one that will trigger when both of the previous stages complete. So when we find the best price and we get the exchange rate, then we're going to go ahead and convert, the price, which we're going to assume is going to come back in dollars, into pounds. And so that's what's going to be the result of this. Now, if the whole thing takes longer than 3 seconds to come back with finding the best price and doing the exchange rate and so on and so forth, then we're going to time out. So the or timeout call, the completion stage method here, basically is saying, if this thing just blocks for more than 3 seconds, we give up. And in that case, a timeout exception will be thrown. And no matter what happens, this method will be called. And depending on what happened, if we have an exception, then one thing happens. If we didn't have an exception, then something else happens. So if we did not have an exception, then we print the price in pounds, because that's what we've got. That's what we get as a result of this. Otherwise, if we have an exception, then we go ahead and print the exception, which would most likely be a timeout exception, or if for some reason the network has failed, it could be a different kind of exception. But this gives you an idea of how to handle timeouts. So we can provide default values, and we can also ensure that the overall timeout operations happen with the overall asynchronous operations happen within a certain bounded amount of time. So that's a real useful set of enhancements and extensions. The next example will illustrate how to use the complete async method. And this is a variant of some things you've seen earlier in some other examples. We're going to multiply some big fractions together. And the particular approach here is going to use a string builder to hold the intermediate results. You'll see why we need that in a second. We're going to go ahead and create an empty completable future. So this is a completable future that has no functionality associated with it yet at all. So we have a completable future called F. And then we say we register this action that will append a string to this string buffer when the completable future is actually run. So remember, we created a completable future. We don't have any code associated with it yet. And we're going to associate this action to run, and it'll append a string when the future is actually called. And then what we do is we say, hey, completable future, please complete yourself asynchronously. And so what this does is it will basically take this supplier lambda, and it will then run this in the common fork join pool. And when that thing is finished, it will, of course, complete the future. So it'll give it an actual result. And that will also, of course, trigger this code to run as well. So what we're going to do here is we're going to start everything running. So the first thing that'll happen is that then run will get called, and it'll append complete async result. Then this supplier lambda code will run. And then when we're all done, we can, well, actually, this will run in parallel to whatever we do here between the point where complete async starts and whatever happens at that point. And then when we want the result, we can say future.join. That will block if the result is not yet complete. If the result's already done, by the time we call join, of course, we'll get the result right back. And then, as you can see here, we're going to convert the result, which will be a big fraction that corresponds to the multiplication, to a mixed string, and we're going to append that here. And then the last thing we're going to do is we're going to display the output as a string. So this just illustrates yet another way to cause interesting things to happen. And it also illustrates the then run method, which will be run at the appropriate point. Okay. Oh, and another interesting thing, this then run method will run in the calling thread. Let's say this is the main thread. That'll run in the main thread, whereas this thing will run in the common fork join pool thread. So they'll run in parallel. Okay, so that's just a little bit more features that are in the completable future framework. That's obviously requires Java 9 or later to get these features. And that's why we don't use them for the programming assignment, because as you probably know, Android only goes up to Java 8. So if you want to use these features, you have to go with some other IDE besides Android Studio, like IntelliJ or Eclipse, and make sure you install the right JRE to make things work.